Okay, I'm going to talk about what HTTPS is. Okay, how does it work? What is it? And I'm going to try and do this for non-technical people. I'm also going to release a PowerPoint video down the track of what it is. So what does the letters mean for a start? Okay, it stands for Hypertext Transfer Protocol. It's the basic language that computers use to talk to each other over the internet. Okay, the S stands for secure. This is the extra layer of armor that is added to protect your data. So how does it work? I'm going to use sort of like a mailbox analogy. Imagine you want to send a secret letter to your bank, but you do not trust the mail carrier. The bank sends an open box. You ask the bank for a way to send the letter safely. They send you an open, heavy-duty security box and keep the only key. So you drop your secret letter into the box and snap the lid shut. The box is locked and even you cannot reopen it. So the mail carrier handles the box, but they cannot see or change what is inside. The bank opens the box after it arrives, and they use their private key to unlock it and read your letter. So in the digital world, your browser, web browser and website use math to create these boxes and keys automatically in milliseconds. Okay, so what does HTTPS do for you? So you can have HTTP without the secure, but I would not recommend going on websites that do not have the secure. Okay, so HTTPS offers encryption or security. It scrambles your data like passwords, a credit card, numbers in an unreadable code while it travels. Data integrity, tamper-proof. It helps to prevent hackers from secretly changing the information while it is in transit. Authentication, identity check, provides or proves that the website you're visiting is the real deal, not a fake copy set up by a scammer. Now, I just want to say that does not mean you can't be scammed or hacked or have your data stolen if you use HTTPS. I would encourage you to have complex passwords, to have multi-factor authentication, use VPN, or a passphrase you could use. You could have what BitLocker password managers. You can also, be careful what cookies you accept, all those sorts of things. Okay, so look, as I said, this is what it helps do, but it's not the only protection you should have. So how do you spot it? When you look at your browser's address bar, the top of the screen, if it uses a HTTPS, you will see a little padlock icon next to the web address, and the URL, will start with HTTPS colon / instead of just HTTPE. All right, so I want to go into a little bit more detail. HTTPS establishes security through a fast, automated digital handshake between your device and a website. And I'm going to sort of step by step. So every time you type a web address or click a link, your browser and the website's computer or server complete 5 steps in, fractions of a second, hopefully. The knock on the door. So what happens? Your browser visits a website after you've typed in, whatever website it is, or, and says, so your browser visits a website and says, hello, I want to connect securely. Here's a list of security tools I know how to use. You walk up to the security bank vault and ask to do business. So that's the analogy. Okay, then the website shows its ID. So what happens? The website responds with an SSL, Secure Socket Layer certificate, and I'm not going to go into that here, but I will in a separate video. This is a digital ID card verified by an official independent security company. This certificate also contains the website's public key, an open padlock, sort of in that types. So the analogy could be the bank teller shows you the official badge to prove they work at the bank, and it hands you an open security box. Okay, So then the third step, your browser verifies the ID. So what happens here is your browser checks an inbuilt master list to confirm the certificate is valid, current, and genuinely belongs to the specific website. So the analogy could be that you check the teller's badge against an official registry to ensure it is not counterfeit. Okay? Then fourth step, creates a secret code or creating a secret code. So what happens? Once verified, your browser generates a brand new temporary secret key. It hides a secret key inside the website's public key, which is the open padlock, and sends it back to the website. Only this specific website has the private key required to unlock it. So the analogy could be you write down a secret code or combination code, put it inside the bank security box and snap it shut. Only the bank has the key to open the box and see your code. Okay? Then step 5, the secure tunnel is open. So what happens? The website unlocks the message, retrieves a temporary secret key, and then sends a confirmation back to your browser. So from this exact moment forward, all data sent back and forth, so like back and forth between you, your browser, the web server, is scrambled using that shared secret key. So the analogy could be here that both you and the bank now use an identical secret combination code to scramble and unscramble every message you send to each other. So the 3 levels of protection this helps create. Okay, so once the handshake, sort of like a digital handshake, is finished, you are protected by 3 distinct layers of security. So no eavesdropping. Well, hopefully, as I'm saying this, you need to remember that anything can be hacked and anyone can spy and look at this. It's not impossible. I'm just saying it helps prevent eavesdropping. Anyone trying to spy on your internet connection, like someone on the same public network, will only see a useless jumble of random letters and numbers. As I said, it's not. I would use a VPN on a public Wi-Fi network. I would not just use HTTPS, and I'd use another other stuff to do there. No tampering. If a hacker tries to alter the data mid-transit, trying to change a transaction amount, the secret code will break and your browser will instantly block the website and warn you. As I said, and then there's no imposters. Ensures your computer is talking directly to the real website like Netflix.com, not a lookalike phishing website designed to steal your login details. Okay, and as I said, this is not, like unhackable. I'm just explaining how it works, but I'm just saying and what it's meant to do. And look, it does help protect you, but it's not completely secure. Nothing is, but like, okay, so look, how would you spot a security to spot and inspect a website security certificate? You don't need to be a programmer. Your web browser handles the heavy lifting, but you can manually open and read the security certificate in a few clicks. So there's a number of steps, and it will depend on the web browser you are using. So open the certificate viewer. So in Google Chrome, you click the site settings icons. It looks like 2 sliders or a padlock just to the left of the website address. Okay, then click the small certificate icon that looks like a document near the top right of the pop-up. Okay, so click connection is secure, then click certificate is valid. Okay, so Microsoft Edge, they all look pretty much the same. There's a click the padlock icon on Microsoft Edge. Apple Safari, click the padlock icon, and Mozilla Firefox. So there's ways and means you can do it. There's YouTube videos, which I will do one myself to show you how to do this. And look for 3 major red flags. Once the certificate pops open, look closely at the General or Details tab for common warning signs of a fake or improperly configured certificate. One red flag is issued to domain mismatch. So what this means, the domain name listed on the certificate must exactly match the website you typed, because it might not, all right, if it's fake. So what to look for, you are trying to visit netflix.com, but the certificate says it's issued to netflix-login-secure.com or a completely random name. Close the tab immediately. Hackers use fake lookalike sites to trick you. Okay, so that's one thing. Untrusted issuer by an organiser. So what this means, certificates must be stamped by a globally recognised neutral safety company called a certificate authority. So what to look for? So you look at issued by line. You should see trusted names like DigiCert, Let's Encrypt, Global Sign, Citigo or Amazon, or if it says self-signed or lists a company name that you can't find or never heard of, your browser should block the site with red warning screen, but don't rely just on that, because people and hackers are getting extremely good. What this means, bad validity dates. So bad validity dates, security certificates are intentionally temporary, usually lasting about a year or less, to ensure the site owner routinely re-verifies their identity and who they are. So what to look for is to check the valid from and to expiration dates. If the current date is past expiration date, the certificate is invalid, meaning the website owner has neglected their security. So, crucial rule here to remember, a HTTPS padlock means the connection is private, but does not mean the website is honest or that it's secure. All right? Today, anyone, including scammers, can get a free valid security certificate for a fake website. You can even generate them yourself. Not that hard, okay? And the padlock only proves that the data is safely encrypted on its way to that specific server. But also, too, as I said, people can still, it's a lot harder, but they can still interrupt that and unencrypt that information. It's not that hard either. Always double check spelling or website address before entering your password and credit details. And if you've got a password credit card online, please, please, please use VPN. All right, so look, that's sort of like the basics in and out of HTTPS. I'm going to do like a PowerPoint video. And look, as I said, this is just to try and explain to you what it is for non-technical people. I hope this is not too confusing. Anyway, thank you for your time.